Hey there! Today we are diving into a programming problem that involves a static array being treated as having a dynamic extent in C++. So, what's the problem here? Well, we have a piece of code that declares a static array and then creates a std-span using that array. However, std-span's extent is dynamic by default, even though the owning array's extent is not. Confusing, right? Let's talk about the solution to this little conundrum. One way to make the span have a static extent is by specifying it upon construction. By using the template parameter char, std, size, static_array, we can make the extent static. This ensures that the span reflects the size of the static array accurately. Moving on with our solution, another way to handle this issue is by constructing the span without specifying any template parameters. By letting the parameters be deduced, we allow the deduce guide to make the extent static automatically. So, simply creating the span without specifying template parameters can also solve the problem. Now, let's wrap things up by discussing another key part of the solution. By including a deduction guide in the form of a template that matches the constructor signature, we can ensure that the span's extent is determined statically. This guide helps in deducing the correct extent based on the size of the array passed in, making the span behave as expected. In conclusion, we've explored how to address the issue of a static array being considered to have a dynamic extent when used with std-span in C++. By understanding the concepts behind span extents and employing the right techniques, we can ensure that our code behaves as intended. Thanks for watching, and remember to subscribe, like, and comment below with your thoughts. See you next time.